Alright guys, I'm going to briefly go over a couple things with solving systems of equations. The first method that I want you to learn is called substitution. A lot of people struggle with that. I really don't understand why, but hey, it is what it is. Anyway, with substitution, what you want to do is pick one of the two equations. We got two of them right here. Alright, so here's number one, here's our second equation. Pick one of the equations where one of the variables is kind of like 1y or 1x. Okay? The only thing in front of the number, the coefficient, should be a positive 1. And the reason I picked that equation is because it's easy to get this variable by itself, and that's the key with substitution. You want to get a variable by itself. So I'm going to do that. I'm just going to solve this, and I'm using a very styling stylus here. Y equals, now what we have here is, I know that's positive, is one of the equations where one of the variables is by itself, and what I'm going to do is plug and chug into the other equation. So in this equation here, equation 1, I'm going to plug all of y in right here. Okay? So let me go to another page and I'll do that. So oh, Nelly. Let's go 2x minus 3y. I'm getting crazy here. Equals, I can hear Miss Smith yelling, negative 2. And I know y equals, I just solved it, negative 4x plus 24. It ain't much to know, but you know what one of the letters equals. It equals all that. So I'm just going to plug and chug here. So we got negative 3 times negative 4x plus 24. And that equals negative 2. Now I can just simply, solve, distribute, whatever I got to do. So negative 3 times negative 4, positive 12x. Negative 3 times 24 is 72. Negative 72. Okay. And pretty sure it's right. I hope I am. Bring down everything else. Now I can, I messed up here. That should be an X. Now I can combine like terms and all that good stuff. So that's 14x minus 72 equals negative 2. So let's be fair. Come on, what's wrong with me? Do both sides. I get 70 equals 14x. Now I can divide both sides by 14. Cancel out. And you'll have x equals 70 divided by 14. Trying to do some math in my head here. I think it's 5. Okay. Now, what you got to do... Sorry, guys, my brain's not working. Plug in what you got now in for x. So I can use what I have here and just plug and chug. Y equals negative 4. I really don't need parentheses at this point. I will put it right here because I know what x is. Plus 24. What we get here is, that'll be negative 20. Just use an order of operations, PEMDAS, y equals 4. Now, there was a part in one of the other videos that said, what is the special thing about a solution to systems of equations. Well, what it is, guys, is these two equations here, I'll underline them in green, okay? Those are linear equations, two lines. And, you know, system equations, if you have a system of equations, it's either going to be you have a solution set or you have nothing. If you think about lines, what could they do? When they intersect at one point. So what this is telling me is that these two lines intersect at this x, this particular x, and this particular y coordinate. Okay? Now, if two lines don't intersect, they can be parallel. That's a no solution. Okay? If you have an answer, a solution, okay, that's a one solution. And sometimes in a system of equations, and we'll put this in a different color, they will give you a line, and then sometimes the second line is the first line. And what happens there, what we would say there is we'd have infinitely many solutions. Okay? There's a bunch of them. They have to be because they're all sharing the same point. So these are the different types of solutions that you could see in a system of equations. Now the next example that I want to do is using something called elimination. I'll just do this one here since it's already there. And let's go ahead and do that. Now with elimination, you could add or subtract both equations to eliminate one of the variables. Okay, that's why they call it elimination. Now, Miss Seidel came up with something very slick that I thought, well, I'm going to use that. Okay, if you notice the same number in front of a variable, okay, look at the signs. If the signs are opposite, okay, I'll just abbreviate, we add. If the signs are the same, we subtract. So same, subtract, opposite, add. Okay, which I thought was very brilliant of Miss Seidel. So I have the same number here. Now I just need to determine, okay, well, my signs are positive and negative. So they're the opposite. So I'm going to add. Now when you add both of these equations, okay, be careful of your signs. Right here I have 2x plus 3x. That equals 5x. Positive 1 plus negative 1, they cancel out. And then you add everything. You add your like terms. You know, draw your line there. 9 plus 16 is 25. Now, I can solve for x. So x equals 5. Now, what can I do with that is basically, I'm going to erase a little bit of this since you already have it. Trying to make this short and sweet. There's no way of making a video that's only 5 minutes long to cover this. So, gee, my stylus needs some dust on it. Okay, a little girly for my taste, but I appreciate it anyway. I'm going to pick one of the equations and just plug and chug what I got here for x. So I'm going to use 2x plus 1y equals 9. Doesn't matter which one. I'm obviously going to have a one solution. So let's plug and chug. 2 times 5 plus 1y equals 9. Multiply that out. Solve for y, guys. And then you go back to box and line it. So I get 1y equals -1. I don't know why I'm dividing by 1, but hey, just to show you. So these two lines intersect at this point. 5, -1. Hopefully this clears some things up. I will talk to you later.